You know, we're always hearing about AI getting bigger and bigger, right? But what if the next real breakthrough isn't about size at all? What if it's about, well, depth? Today, we're going to dive into a totally new AI architecture that's designed to teach machines how to actually think, not just repeat what they've seen. This is GSA HRVA. So let's be real. We're living in a time with some incredibly powerful AI. I mean, these things can write software, they can create stunning art, they can pass the bar exam, but they have this one kind of weird, persistent problem. They just make stuff up. This whole thing, we call it hallucination, and it points to a huge paradox at the core of AI today. How can something be so brilliant, yet so confidently wrong? On this right here, this really gets to the heart of it. On the one hand, you've got the mind-boggling scale of today's models, trained on just oceans of data. But on the other side is the reality. Their reasoning is, weirdly enough, super shallow. They are fantastic at spotting patterns and all that data, but when it comes to the kind of step-by-step logical thinking that we'd call real understanding, they kind of fall flat. And there's actually a name for this. Researchers call it the AI reasoning gap. It's this idea that our current strategy of just making models bigger and throwing more data at them is hitting a fundamental limit. It's like we're hitting a wall, a point where more data doesn't actually make the AI any smarter in a meaningful way. And hey, this isn't just some vague idea. The research paper that introduced this new architecture spells it out. This quote here basically says that the very blueprint of today's AIs physically limits them from solving certain types of problems. They're literally stuck in a kind of computational box that keeps them from doing the hard, deep thinking that true intelligence requires. So, if the old blueprint is hitting its limits, what does the next one look like? This is where things get really interesting. A brand new architecture enters the scene, and it's designed from the ground up to close that exact reasoning app. And here it is, get ready for this one. The governed, self-adaptive, evolutionary, hierarchical, recursive, variational autoencoder. Yeah, it is an absolute mouthful, I know. It sounds ridiculously complex, and that's because it is. But here's the cool part. Every single piece of that name describes a specific superpower that this AI has, and we're going to break them all down. So let's just forget that crazy long name for a second and focus on the goal. GSA HRVA is not about building a fancier parrot that can just mimic human language better. No, this is an attempt to build a system that can actually reason, one that can evolve its own problem-solving skills, and, this is so important, do it all within a safe, controlled framework. So how in the world does this thing actually think? Let's get into the mechanics, the real nuts and bolts. There are three key innovations that give this AI its power, and they all work together to create this really dynamic reasoning engine. Okay, so it all boils down to these three pillars. First, you have hierarchy. Just think of a company with managers and workers. Simple enough. Second, recursion. This is basically the AI having a deep brainstorming session with itself, just looping over its own ideas to make them better. And third, evolution. The AI literally uses a survival of the fittest approach to figure out the best ways to solve a problem. Let's zoom in on that first idea, the hierarchy. This process, they call it hierarchical convergence, is what keeps the AI from getting lost in the details. So you have these low-level worker modules that just grind away on the nitty-gritty parts of a problem. Once they think they have a solution, a high-level manager module steps in. It looks at the big picture, finds the abstract patterns, and then points the workers in a new direction. This constant back and forth lets it think incredibly deeply without just spinning its wheels. And that brings us right to recursion. This is the AI's ability to think about its own thinking. It doesn't just spit out an answer and call it a day. It takes its own output, reflects on it, and refines it over and over again. You can think of it like the AI having an internal debate with itself, challenging its own ideas to get to a stronger conclusion. It's the difference between a gut feeling and a really well-thought-out judgment. Okay, but let's be real. All that brain power, without any guardrails, that could be a recipe for disaster. This new architecture isn't just about making AI smarter. It's about building trustworthiness right into its core. And this is done through a really clever 5-level governance system. It's like a series of nested safety nets built right into the AI's DNA. The key thing to get here is that safety isn't an afterthought. It's not some filter they bolted on at the end. It's a fundamental part of how this thing thinks and learns. All right, let's just walk through these layers, starting from the ground up. At level 1, you've got your basic operations, just taking in data. Level 2 acts like a regulator, making sure the whole system stays stable. Level 3, that's the engine room. That's where that whole survival of the fittest evolution thing happens. Level 4, now this is where it gets really cool. This is the adaptive layer that helps the AI refine its own ability to reason. And at the very top, level 5, the identity layer. Think of this as the AI's conscience. It's constantly checking for those hallucinations and making sure everything is logically consistent. And for anyone out there a little nervous about an AI that can literally evolve itself, here is the single most important safety feature. The system has something called a modification gatekeeper. This means that any big, high-level changes the AI wants to make to itself have to be approved by a human, period. The AI can suggest ways to get better, but it absolutely cannot evolve without our say-so. Okay, so it sounds amazing on paper, right? A brilliant design, but the real question is, does this thing actually work in the real world? Let's look at the numbers. First up, remember that hallucination problem we talked about at the very beginning? Well, this tackles it head on. That level 5 identity layer means the AI is way better at knowing what it doesn't know. The result? A 15% drop in made-up facts compared to other models. It's learning when to just say, you know what? I don't know. It's also shockingly efficient. Because of that smart hierarchical design, it doesn't have to just guess and check wildly. It finds good, stable solutions 3 times faster. It doesn't just think deeper, it gets there with way less wasted effort. It thinks smarter, not harder. Okay, get ready for this next number because it's a genuine showstopper. In a world where AI models have billions, sometimes even trillions of parameters, this model gets these incredible results with just 7 million. This is just powerful proof that a smarter design, not just raw size, is the way forward. It's pure computational elegance. And now for the main event, the ultimate test of actual intelligence. On the ARC-AGI benchmark, which is this notoriously tough set of puzzles made to measure true abstract reasoning, GSA HRVAE scored 45%. Now, 45% might not sound like an A+, but let me tell you, it nearly doubles what standard models can do. In the world of AGI research, that is a seismic shift. So, what does this all add up to? What does a more efficient, less gullible, deeper thinking AI actually mean for us, for the real world? Well, the potential is just staggering. Well, because this thing can handle all sorts of data, text, images, graphs, you name it, it opens up some incredible doors. Imagine in bioengineering, it could simulate something as complex as how cells regenerate. For robotics, it could help build machines that can truly adapt to messy, unpredictable places. But maybe the biggest thing is, this is a huge step toward building AI for science and industry that we can actually trust. And that really brings us to the big takeaway here, the final critical question. This research is a blueprint for not just a more powerful tool, but for a true partner in reasoning, an AI that can improve its own thinking and has integrity baked right into its core. So I'll leave you with this. If we can actually build that, what problems couldn't we solve together?